about how we can use these equations of the motion, as well as when object is falling under the influence of the gravity, object is moving vertically upward or downward. Or if we take the complete motion, how we can use these equations of the motion. These are the 4 equations of the motion. Yesterday, we did the derivation of each of them. Now, motion under the gravity or influence of the gravity without air resistance, if we ignore the air resistance, if we ignore the air resistance and we consider there is no air resistance, these type of questions you can solve in 2 ways. Either you divide the motion into 2 halves, like you divide the upward motion and the downward motion separately, or you consider the one complete motion of an object. I'll give an example. It won't make difference to the final result. For example, if we separately or independently solve the question for the upward and the downward motion, so if we separately solve the question related to the upward and the downward motion, an object is there which is launched vertically upward. So what will be the initial velocity of this object? What we call initial velocity, we called as u. When the object reaches the maximum height, what will be the final speed of this object? The final speed of this object will be 0 meters per second, because at the maximum height, the object will stop for a very short time. Momentarily, it will stop. And whenever object is launched vertically upward, so it will always decelerate or the speed will decrease. So the deceleration will be same as the acceleration due to gravity or the force of the gravity, which is 9.8 meters per second square. That is when an object is moving upward. Vertical motion, we take it separately. But what if the object is moving downward? So initial velocity will be 0. For falling objects, the initial velocity is 0. What about the final velocity? When it hits the ground or just the moment before it hits the ground, the final velocity will have some value. We represent the final velocity as v. And what about the acceleration? The acceleration will be due to gravity, which is 9.8 meters per second square. That is, if in a question, we have only the upward motion or we have only the downward motion. 2 motions are separately given in the question. What if we have a question in which an object is thrown and there's a complete motion? So if we have a complete motion of an object is launched or thrown vertically upward from certain height above the ground. And example, this is a trajectory or the path which the object follow. So we have to specify a direction here. So just try to make a standard that anything which is pointing upward, what we'll consider? Positive. And anything which is pointing downward, we'll consider as negative. So if we launch an object, what about the initial velocity? Because we launch the object vertically upward, so initial velocity will be positive always. Then what about the final velocity? It depends on the question, like in the question, that which point we want the velocity. If I need the velocity at any point when the object is going upward, in that case, the final velocity will be positive. Like example, if I say, what is the final velocity at this point? So you will consider the final velocity to be positive. But if I say, what is the final velocity at any point when it is coming down? So in that case, you have to take a final velocity as negative. So it's important to take the sign of the final velocity, but throughout the motion, if it's going up, all the upper directions we consider positive. So all the vector quantities which are pointing downward will be negative. Then another thing is the acceleration, because whenever object is thrown vertically upward or it is moving downward, the direction of the acceleration is always toward the center. Means the acceleration is always pointing downward. So if I say, what is the acceleration at this point for a complete motion, you will take as negative 9.8. Even if I say what is the acceleration at this point, you will also take as negative 9.8, because all the vectors which are pointing downward, we are considering them as negative. So all the position, the acceleration is pointing downward. That's why we took as negative 9.8. Is it clear till this point? Yes. Then what about the displacement? So any displacement above the origin, like this is a point where we launch an object. So this is the origin. So if we launch an object, any displacement, like if I say, what is the displacement at this point or at this point or at this point, any displacement above the origin, even it is going up or going down, all the displacement will consider as positive, because displacement is actually the distance we measure from the launching position. So when we draw an arrow to show these displacement from the launching position, all the arrows will point upward. Like if I say what is the displacement at this point, arrow will point upward. Displacement at this point, displacement, so all the arrows are pointing up. So any displacement above the launching point will always be considered as positive. But any displacement below the origin, like example, an object is at this position. So when you draw an arrow to represent that displacement, so you will consider that displacement to be negative. Acceleration is always downward. That when you complete take the full motion, the value of the acceleration you will always take as negative 9.8 meter per second square for a complete motion. But for if you have two halves of the motion, the upward or the downward in the question, so if it's an upward, you will take as negative, but if it's a downward, you will take as positive. So it's very important. The sign conventions are very important whenever you solve a question related to motion under gravity. Is it clear till this point? Anyone having a doubt or a question?
No, sir. Clear.
So no doubt. Now I'll solve a question by using the two methods, and you will find that if you use the first method or the second method, you will get the same result. So example, say an object is there, launched from the ground, vertically upward. So there's an object you launch from the ground, vertically upward, and the trajectory which this object follow, it rise up and then it come down. You want to find the total time of the flight, like how much time it will remain in air, or we want to find the total time of the flight. I can solve this question two ways. I can consider the upward and the downward motion separately, and I will work out the time to go up, and the time to come down will be same because the acceleration is the same, or acceleration and deceleration. So just I will work out the time to reach the maximum height, and the total time of the flight, like how long it will remain in air, that will be twice. Or I can also consider the full motion, and I will solve with the full motion. Example, if I consider the half motion, if I'm considering the half motion, any one of the half I can take an upward when it is going up, or I can also take when it is coming down. I will get the same result. So example, I launch an object with a speed of, the initial speed of 30 meters per second. So the launching speed, the initial speed is 30 meters per second. And I'm considering an upward motion now. So for that upward motion, what is the U here? 30. Now I'm finding how much time it will take to reach the maximum height, and the total time of the flight will be double. What is the final velocity at the maximum height when it reaches the top?
0.
It will be 0. Because when object is launched vertically upward, it will always have a deceleration. So the speed is maximum at the beginning. And when it reaches the maximum height, the speed will decrease. And at the maximum height, it will be 0. What I should take the value for acceleration, negative 9.8 or positive 9.8?
Negative 9.8.
So I should take as a negative 9.8 meters per second square. Now I want to find the time to reach the maximum height, so I can use the first equation of the motion, which is v equals u plus at. So v is the final speed, which is 0. U is the initial speed, the launching speed, that is 30. The acceleration is due to gravity, which is negative 9.8, or deceleration. So it will be 0 equals 30 minus 9.8 t. 30 will move other side. So minus 30 is equals to minus 9.8 t. Negative will cancel with negative. So 30 divided by 9.8. What's the answer for this? The time to reach the maximum height?
3.06.
So the time it takes to reach the maximum height is 3.06 seconds. Because we ignore the air resistance, so how much time it will take to come down? It will take the same time to come down. So what will be the total time of the flight? The total time of the flight will be equals to twice of this. So it will be 2 multiplied by 3.06, which is 6.12 seconds. So that is the time it takes to reach the maximum height and then come down. That is when we consider the half motion. Okay. Is it clear? The half motion?
Yes.
Now, if we consider the full motion, I can also solve this question by considering the full motion. So if we consider the full motion, we launch an object. The object reach the ground. First, we launch with a speed of 30 meters per second. So u is there 30. When it come down, it will have v, but we don't know that v. We don't know that. Now, what about the displacement of this object when it returned back to the same level? Vertical displacement, not horizontal, vertical displacement. What is the vertical displacement for this object? What will be the, I launch an object, it goes up and then it come back to the same level. What is the vertical displacement?
0.
Good. The vertical displacement will be 0. Because the object returned back to the same level, that's why the vertical displacement is considered to be 0. What will be the value of the acceleration I'll take for the full motion? It is always negative 9.8 meters per second square, because the direction of the acceleration is always downward. Now, we have S, we have U, and we have A. So which equation of motion is valid? Like, I cannot use this equation because I don't know the final speed and I don't know the time. If I use the equation, S is equals to ut plus half at square. 2as is equals to v square minus u square. If I try to use that, like v square is equals to 2as plus u square, I cannot use that because I don't know the final velocity, and the final velocity is not our subject. Like, we don't need the final velocity of this object. We want to find the time to reach the total time of the flight. So final velocity is not our subject. I can use this equation, but it's not needed. What I need is the time to the total time of the flight. So if I need the total time of the flight, I can use this equation. S is equals to ut plus half at square. So what is the displacement? I'll substitute 0. What is the initial speed? 30. What about the time? We don't know. Plus half. Expression is due to gravity, so I'll take negative 9.8 and then t square. Now we simplify this equation. So 0 is equals to 30t minus, because 9.8 divided by 2, so 4.9 t square. This 30 will move other side, so it will become negative 30t is equals to minus 4.9 t square. If I simplify this, the square of this will cancel with t, and then it will be negative will cancel with negative, so it will be 30 divided by 4.9. What is 30 divided by 4.9? So we get
6.12.
So we got 6.12. The same answer we will get if we divide the motion into two halves, or we consider that a full motion. So it won't make difference. Is it clear?
So
Yes.
which way is better?
It depends on the question. Like sometime in the question, they give you the complete dimension of the motion. Like they give that the object is having a complete motion. I prefer this one. I prefer this one, that you try this one and you will get the answer directly. But this method will work, but you have to divide the motion into half.
Okay.
Why not considering a horizontal displacement? Because the next part of the topic is a projectile in which we'll consider the horizontal displacement as well. Like the horizontal motion. Because whenever we are treating the motion of an object, we treat the horizontal and the vertical motion separately. So even though this object is having some horizontal displacement, but we are not using that, but like we are ignoring right now. We are only dealing with a vertical motion. Next topic is about the projectiles, which is about the horizontal and the vertical motions together. Anyone having a doubt or a question till this point?
No, sir.
Okay. So we'll move on to the next part, which is about some examples related to this topic. As you can see here in this question, a small stone is fired vertically upward by the catapult with a speed of 10 meters per second. Find the maximum height the stone can reach. So we need the maximum height the stone can reach. In this case, the question is only like one half of the motion. The question in the question it did not give, so we can use only the first half of the motion in which the object is moving vertically upward. So when the object is moving vertically upward, initially it will have some speed. So what is the initial speed? The initial speed is 10 meters per second. We need the maximum height. What will the speed at the maximum height? The speed at the maximum height will be 0. What about the acceleration, positive or negative?
Negative.
So we'll consider as negative. And the reason for selecting this example, because in this example, how it is done, if we don't consider the acceleration, because the sign convections we don't use, so the final answer of a displacement will get different value. Like not the value, the sign will be different. So here the initial velocity is 10 and v is 0. And what about, yeah, why they choose 9.8? Just I'm giving an idea about if you choose positive 9.8 or negative 9.8, what difference it will make. It will only make difference to the final answer, the sign of the final answer, not the magnitude. Because what will happen, example, in this question, if we consider acceleration as 9.8, so when we solve by using the equation of the motion, example, we are using this equation, v square is equals to u square plus 2as. So we have the initial speed, as 10, we have the final speed, which is 0, and we took the acceleration as plus 9.8. It should be negative, but example, if we took plus 9.8. So when we substitute the values and find the displacement, the vertical displacement, what we got minus 5.1. So what does it mean? Look, in terms of physics, the sign refers to direction. So what does it mean? Because we know acceleration is always pointing downward. So if I take acceleration, the downward as a positive, so anything which is upward will be negative. Because the displacement is upward, that's why instead of getting a value 5.1, we got negative 5.1. So what this negative sign shows, this negative sign only shows that the displacement is vertically upward. So negative sign just shows the direction. Is it clear?
Yes.
Any question or doubt till this point?
No, sir.
You can use mic, chat, or screen annotation in case if you have any doubt or a question. So I advise, like whenever it's an upward motion, instead of taking positive, take as negative. When it's a downward, take as positive. When it's a full motion, take as negative. That's it. So you won't get confused. The reason for selecting this example, just to give you an idea, what if you selected 9.8 as a positive one, so you will get a negative answer, which only shows that the object has displaced upward instead of downward. So in this question, it's related to the equations of the motion. A car accelerates uniformly from stop with a rate of 6.1 meters per second square. So acceleration is given. If it was a deceleration, like in the question, if they use the term deceleration, we'll substitute as negative. But because it is acceleration, so we'll take as positive. Find the displacement and the speed after 0.82 seconds. This is a horizontal motion. Remember one thing, the horizontal motion, the acceleration is not equals to gravity or 9.8 meter per second square. If you take as 9.8, it will be considered as wrong. So acceleration for the vertical planes, it is, if without air resistance, it is 9.8 acceleration or decelerations. But on the horizontal plane, it depends on the thrust or the force of the engine and the resistive force. And acceleration on the inclined surface is a bit different. That we'll do as well. All of these examples are without air resistance. We ignore the effect of air resistance. Because why we ignore the effect of air resistance? As we are applying the equations of the motion are conditional. What is the condition for using the equations of the motion? The condition acceleration must be constant. So if there was an air resistance, then the acceleration won't be constant. If the acceleration is not constant, it means we cannot apply these equations. That's why these equations of the motion are always applied on a motion in which the acceleration is constant. So an acceleration for vertical planes or horizontal planes with air resistance cannot be constant. So a car accelerates uniformly from stop. So the car was initially at rest and it has an acceleration of 6.1. So this is acceleration. We have to find the displacement after 0.82 seconds. So that's the time interval. The initial speed is 0, the time is 0.82, and the acceleration is 6.1. What we need the displacement and the speed. We need the final speed. So the best thing to solve such question, you can note down all the 4 equations and apply these equation, check in which one you have only one unknown. The equation with only one unknown, that equation is useful. Like if I write all the equations of the motion, so we have V equals U plus AT. We have S is equals to UT or V plus U divided by T divided by 2 multiplied by T. We have S is equals to UT plus half AT square. And we have 2AS equal V square minus U square, or you can also write V square is equals to 2AS plus U square, or U square plus 2AS. It's the same thing. Now, if we want the V, like if we check the first equation, we have the time, we have the acceleration, and we have the initial velocity. So we can use the first equation to work out the final speed. So what will the final speed of this object? The initial speed is 0. The acceleration is due to gravity, which is not gravity. The acceleration is due to the horizontal plane, and the time is 0.82. So what's the final speed of this object? What is the final speed of this object? 6.1 times 0.82. 6.1 multiplied by 0.82.
5.002.
So we'll write the answer into like 3 significant figures. So 5 meters per second, or 5.00 meters per second. Now, we need the displacement. So any of the formula now we can use, because now we have U, we have V, and we have T. So we can use this formula to work out the displacement. So displacement initial velocity is 0. The final velocity after 0.82 second, that is 5 divided by 2 multiplied by T, which is 0.82. So it will be 2.5 times 0.82. That will give us the displacement. What's the answer for this?
2.5 0.05.
So 2.05 meters. That is the displacement. Is it clear, this example?
Yes, sir.
Next is a motion like example. This is also a word example. As you can see in this question, a boy throws a stone vertically up into the air with a velocity of 6 meters per second. So initial velocity is 6 meters per second, which is vertically upward. So what I will take as initial velocity as 6 meters per second positive. Why positive? Because we consider anything above the origin is a positive direction and below the origin, like anything pointing downward is negative. And all the displacement above the origin, like the point of launching, because the origin will be here, the point where we launch. So all the displacement above the origin will be considered as positive and below the origin will be considered as negative. The stone reaches a maximum height and falls into the sea, which is 12 meters below the point of release. So we release, this is the point of release, so that it is 12 meters below the point of release. So when I work out the displacement, I will draw a downward arrow for this displacement. So if we have to draw a downward arrow for the displacement, what I'll consider that as negative 12 meter. Even though it's 12 meter, but because it's a displacement, so displacement must be negative. We need, in the question, calculate the velocity at which the stone hits the water surface. So we want to find the final speed, the speed at which it hits the water surface. And so other factors are there. So equation, which as I mentioned, you can use multiple equation depending on what is given to you. So if you are using this equation, v square is equal to u square plus 2as. So we just substitute the value of the u is 6. So it will be 6 square. Then for the acceleration, because as I mentioned, for a complete motion, acceleration we always take as negative. So we took as negative 9.8 and the displacement we took as negative 12. So negative, negative, positive, when we simplify, we got 271, which is v square. And then v square is equals to, if v is there, we have to take an under root. So under root 271. So root 271, what we get? We get 16.47 meters per second. Which sign I should take, positive or negative, for the final velocity? Because the direction of the final velocity is downward. So if the direction of the final velocity is downward, what I will get the magnitude, because when we take a root, square root, we got two roots, positive and negative. But which one I should take? I should take as negative 16.47 meter per second. So what this negative sign indicates, this negative sign only indicates that the velocity is pointing downward. Is it clear, this example? In the question, they mentioned that point. They mentioned that a boy throw a stone vertically up into the air. So the initial launching speed is 6 meters per second. That's given in the question. So the initial launching speed was given in the question. And we need the total, like the velocity at which it hits the sea. So that's why we took as negative 12. It was below. Yeah, it travel extra distance upward and then it comes down. But this, when we are substituting the value of s is a displacement. And whenever we consider a displacement, we don't bother about, like example, if I say I'm at position A, I move to position B, then I move to position C, and then I move to position D. But if I say what is my displacement, to work out the displacement, we just draw an arrow from the start till the end. So displacement does not depend. No, displacement is 12 because the displacement is refers to the distance from the start till the end, irrespective of the motion. Displacement does not depend on how the object moves, displacement is actually the shortest distance between the 2 points, which is always in a straight line, and it is between the starting position and the final position. So that's why we don't bother about, even though it moves up and come down, but the distance 12 meter was below the origin, so that it means the displacement is 12 meters. Is it clear? Any question or doubt in this? So if I say, what is the time it takes to hit the, what will be the time it takes to hit the water surface? So how to work out that time? If a question is calculated time it takes to hit the water surface. So what we'll do, we can use like V is equals to U plus AT. And we'll solve in the same manner, or you can also substitute the value of the displacement, like use S is equals to UT plus half AT square. You have the value, you have the displacement, you have the initial speed, so you have the acceleration, so you can also work out the time. But what displacement you will substitute? You'll substitute as negative 12. Okay. So whenever we are taking a full motion, we take the sign convections. If we can divide, otherwise, if student want to solve this question by dividing the motion, so first student has to find the time to reach the maximum height, then the time to return back to the same place will be double, and then student have to calculate this as well. The time it takes. So like time t1 we have to calculate, then time t2 we have to calculate, and time t3. And then we add the total time and we'll get the time for the flight. So instead of that, the simple way is, if you use this equation and substitute the displacement negative 12, you will get the total time directly. So that's the advantage of using this equation of the motion collectively rather than dividing the motion into halves. Like what we have to do is, it is launched at a speed of 6 meters per second. The final speed will be 0. The acceleration will be like negative 9.8 meter per second square. So first, using this equation, V is equals to U plus AT, we'll find the time it takes to reach the maximum height. And then this example T1, then the time to come back to the same level where we launched, that time will be T2. That total time will, like, it will be twice of the time to reach the maximum height. Then now it is coming down. When it is coming down, now what we have to do, first we have to work out the speeds. Like we know the final speed at which it hits. We know that vertical displacement is there. We know the acceleration will be negative 9.8, and we have to find another time, that is T3. So if you want to work out the total time, it will be T1 plus T2 plus T3, which will make it difficult to do this. Yeah, it will turn out to be quadratic equation, and then you will solve the roots of the quadratic equation. We can calculate T3 as well. How we can calculate T3? If we know the velocity at which it is hitting. So example 16.4 meters per second is there. We know the S, we know the A, so we can work out T. Like using an equation first, V is equals to U plus AT. We'll have the speed at this point we called U. After working out the U, we'll work out the displacement. Not negative. When you divide the motion into half, you will consider all the distance as positive and even the velocities. When you divide the motion into halves, you don't have to divide positive and negative signs. All velocities will be positive. But when you divide the motion, like you take the full motion, then it is important to take the sign conventions. Is it clear?